Tech for ID.
Tech for ID.
Tech for ID.
Technology for Indonesia.
Technology for Indonesia.
Technology for Indonesia.
Technology for everyone.
Technology for everyone.
Technology for everyone.
Hello everyone, welcome back to another live Tech Talk session. And today we are going to get a closer look on the data scientist. I'm Intan and I'm going to be the host today. And as usual, Tech for ID has always been bringing us the best speaker, best people in the industry to share to us about a lot of their knowledge, experiences. And today we are going to learn from Kirill Odinstov. He is the head of data science of Home Credit Indonesia. It's a tech-based financial company. So let us say hello to Kirill. Hello, Kirill. How are you?
Hi, Intan. I'm good. Thank you for having me.
Thank you so much for being here. It's such an honor and a pleasure to be able to talk to you today. And so, Kirill, I have been giving a little bit of a background of you, but we would really love to know more about you. So would you please give us a little bit of more introduction about yourself, please? Thank you.
Well, basically, I'm originally from Czech Republic, from Praha in Indonesian and actually in Czech as well. There I've been working in all my career, basically either in data analytics or in modeling. Before going to Indonesia, I was working in Home Credit International in our headquarters when I was heading a team of scoring analysts. And then I moved to Indonesia to be the head of data science. And in general, I enjoy mathematics and logic and all this kind of stuff. Yep, this is it.
Thank you. Thank you so much for the intro. And yeah, we are very enthusiastic to learn more about it because the topic is quite new, yeah. So yeah, and so for the audience here, we would love to share to you guys that today you can absolutely drop any questions on the YouTube comment below. So if you have any questions, you can just drop it and I will read it and Kirill will absolutely answer it for you. So we are going to start with the list that I have of questions. We're going to start with what is data science? And in general, would you please give us a small introduction about data science?
Mm-hmm. Basically, this is very difficult questions. As you correctly mentioned, this is very new field. So I would say each company has different definition, or even each person probably. My personal definition would be data scientist is a person who is trying to help business to make decision on vast number of data, right? And he's helping the people to do the decisions on the large data, right? Because as a human, we can only observe few data points together, right? We can connect only few data points, whereas the computer can help us, or the machine, to actually connect all the data points, right? And I believe like the computers are not replacing the humans, or data scientists are not helping in this. They are actually helping to assist the humans to make better decisioning. And I believe this is at the end of the day, the goal of data scientists and their teams, to help other departments to make smarter decisions faster, sometimes more automatic, so they can focus on the stuff that machine cannot do yet and will not be able probably in some time.
Mm-hmm. So data scientist is a profession, right?
Yes.
But what about data science? Would you please give us like a little bit of general description of what it is?
Well, again, it's what data scientists do, right? So mostly it's about modeling, right? Mm-hmm. So mostly it's about taking some historical data and trying to do some future-looking prediction, right? But also there's exceptions. There are also data science tasks that can be done on this, like only without prediction, right? But just helping understanding you some past data. But most of the time you're trying to predict something, right? with data science. So for example, like a long time ago, this is a very typical example, by the way, long time ago in risk, when you went to get a loan, right, there will be a human assessing how likely you are to pay it back, right? This is the way of the past. This is mostly no longer happening, right? You actually have some humans who built a model, right? And this model, based on some historical data collected over a long time, is predicting how likely is each person to pay. And based on this, we are doing our decisioning, right? And again, the humans are deciding what risk is acceptable and what risk for what kind of product is acceptable, right? Because our ultimate goal is for clients to pay us, right? We don't want to overdebt someone, right? And it's also the goal of the client, right? So basically, if I have one example, this would be it.
All right.
But you can do in other departments as well, right? This is just a risk example because it's the simplest. But you can again automate or help smarter decisioning and faster decisioning on any department, right? You can decide which clients it's best to call, when it's best to call them, right? Because you don't want to bother them.
So that is a very interesting answer, because that is also emphasizing how important it is to have data scientists and how important it is of the existence of data scientists. And how do we become a data scientist?
Well, I would say by practicing. Yeah. Like I would definitely not recommend only theoretical training. Yeah. I would definitely recommend to understand some basics of, let's say, statistics and to learn some methods. But data science is more about practice and and some kind of understanding of what you are doing and thinking, critical thinking. And the best how you can learn is actually by doing it, right? So don't be afraid. Just start doing it. There is either in your company, you can, if you are working in some company, and I'm more talking to public, right? So if you are working in some company, just try to think of use case, try to do it if you have some free time in between tasks, right? And present it to your bosses. It will be good practice for you, and maybe it will help the company. If you are not working anywhere where there is such opportunity, there is amazing platforms like, for example, Kaggle, where this is like American website, but it's international basically now, right? Where companies are posing their problems, and you can, start building models on their problems, and there will be some evaluation and can win also nice prizes. By the way, I'm not propagating Kaggle. I'm just saying there's nice data sets and nice problems. So you can try on these problems, and you will be able to really make your data science practical, and you will learn like how to improve it. So the best thing would be start by doing it. Yeah. Slowly, and you'll get there.
All right. Slowly, but you'll get there. So what are the skills that we should have as a data scientist?
I believe very important skill would be scripting, right? Like you don't have to have exactly IT background, but you need to be able to write proper scripts and work in scripting languages. Like this is very important. Then, of course, some statistics and mathematics will be helpful, right? Because you need to understand. But for me, it's also like critical thinking, basically, challenging, asking correct questions, right? And also be able to explain the stuff easy that you do, right? Because your client is not computer, your client is some other department, right? And maybe they are not in such detail as you are, so you must be able to explain it in easier words to them. Otherwise they will not trust your solution, and they will not want to risk using it, right? So I would say these are very important skills from my perspective for data scientist.
That is really interesting, because yes, sometimes when it comes to technology, we kind of have this language gap of the people who are working more into technical and the just common people who are actually using the technology. But yeah, we basically need like a more humanized language in that sense. Is that true?
Yeah, I would say so. You need to do it, right? You need to persuade the people to use your solution. So you need to explain it very easily, right? So even hard algorithms, you should be explained in a way that your grandma would understand.
That is very funny. All right, so how do you look data scientists as a career?
Well, I think it's a very interesting career choice. I think it's good. I think there is very growing demand for data science in the markets in Europe and especially in Asia. I see in both markets there's very high demand for it. So I believe as a career prospect, it's a very good one. But I would encourage everyone just to really do data science because they want to do it and it's interesting for them, not because it's sexy job to have, right? Because you will be always the best doing what you actually care about, not what is sexy right now. Because in 10 years something else will be the sexiest job. Now it's like data science everywhere. It's a buzzword that's being used a lot. But choose really if you like it. Definitely go ahead. I think it's a great career.
So when it comes to countries or like regions, where are the most where is the highest demand of data scientists?
Hard to say. I would definitely say Asia has much higher demand than Europe. Yeah, because Asia is, from my perspective, from how I see it, I'm not talking in general, but how I see it, I see Asia to be more dynamic and more growing right now. And I see even by the demand of data scientists that it's higher here, right? You have much more startups. For example, even in Indonesia, right? There's quite a lot of startups. All startups, of course, will benefit highly from the data scientists. So I believe here it's much higher demand.
All right. And what are the benefits of data science for financial institutions, or maybe like different aspects?
Well, I believe it's basically data-driven decisioning for the company, right? Even without data scientists, we can do data-driven decisions, but data science makes it like on other level, right? So you can automatize some decisioning, help the people, like if I don't talk about finance specifically, like also typical use case, for example, for doctors, right? It's quite well known that, for example, let's say you have a patient, you measured some values for the patient. Let's say you have some, I don't know, some Röntgen, right? You have some kind of blood values. And as a doctor, of course, you know few cases. You as a doctor can go through, for example, through 10 cases and you have like 100 cases that you experience in your career or 1,000. But the machine has access to millions of cases, or billions basically, right? Theoretically, right? So the machine can help the doctor to also like a little bit, give him advice, right? What to do, and doctor can focus on it. But if we talk about financial companies, it's mostly about automation, making smarter decisions. Yeah.
All right. And are those technical concepts that we should know about, about the data scientists, like the field? And yeah, before we start to learn what is data science, is there a technical concept that we have to know?
I wouldn't say, just basically when you start learning, my advice would be to really try to understand what you are learning, right? Because there is a lot of, if you want to be good at something, you need to be somehow differentiated from, you have to have some barrier of entry, let's call it, right? So you have to pass it, and to run a data science model, anyone can, right? I mean, if you sit down with anyone, you can just find in Google, and there is a lot of how to do, I don't know, voice to text, how to do text mining, right? So you can find very easily some script and some guide how to do it. But what they don't teach you is how to exactly use it, on which use cases, how to interpret your results. And this is the hard part. So my suggestion would be, it's very hard to do it unless you really understand the methods. So I wouldn't say there's specific technical skill that is needed or anything, but you really need to understand your methods.
Right. So what are the common issues that are actually being solved by data scientists for companies in general?
Well, it can be any decisioning that should be made fast on large quantities of data. But I will be more specific, right? Because I believe I'm answering the same way, so I will be more specific. So for example, in home credit Indonesia, we are trying to answer questions like, again, how likely the client is to to pay well, right? Because we don't want to overdebt client, or how much installment he can afford, right? Because we just want to make sure that they don't get into some debt, the clients, that they cannot pay, because it's bad for them, it's bad for us, right? Then, for example, let's say you have a department that is receiving emails. So you can prioritize the emails automatically, right? Because some people are asking for questions that needs to be answered, but maybe they can wait a little bit. It's some general question, but maybe some people have general concern, or they need some answer quickly. So you can prioritize using data science, right? Or for example, you can use it to offer proper product to your client, so they don't get angry with you by you offering them something that is irrelevant, right? Or for you not to call them too much, right? Or you can try to optimize this one at least, right?
So that is a really great pointers of why, like, what type of problems that we can benefit or we can solve by hiring data scientists. And is there any challenges, or like what are the common challenges that you might be facing while you are handling data science?
Like, I would say biggest challenge with data science is that it's very hard to know when you are finished with your model, let's say, right? Because let's say if you work in some departments, let's say you have to create some application. If the application works, you are done, sort of, right? In data science, you can always build model, but not always this model will have some reasonable output, right? You can build some model, but it has no real impact on the business. And making models that have impact on the business and are used properly, I would say this is one of the big challenges of data science. Also, again, since it's a little buzzword, the data scientist needs to also, it's a challenge to set up expectations correctly, right? So sometimes people are expecting too much of data science, that it cannot do at the moment, or cannot do in the given time, right? That it's not so easy. Or sometimes other way around, people still don't trust the data science because it's fairly new, right? It's very automatic, and it's challenging the way how the standard work was being done for many years. So I would say these are the two challenges: either too much enthusiasm or not enough of enthusiasm of your final client.
Okay, all right. That is a lot. Like, it's because we are not talking about like specific cases. So when we are listening to the answer of those general answers, like, well, it's like a lot to grasp. And what is machine learning algorithm, and why is it important?
Well, again, definition is quite vague. Some people already define some statistical models as machine learning algorithm. Some define more like more advanced models only as machine learning. Some put there deep learning, some not. So the definitions vary. But basically, if I say the most general definition, it's something that takes historical data automatically, and on this tries to build some predictive model that will be predicting the future, right? So you take, so basically you need two things usually, not always, but usually you need some data and something you are trying to predict, right? And basically, then the model, then you are seeing, you have some algorithm that is trying to make sure what your model that is built is close to reality on those who you observe, where you observe the reality. But also you have unsupervised models, right, that simply try to cluster people who are, for example, similar, right? And there you have no supervision, or you don't, yeah. So basically like this. This is my definition of machine learning, but I'm pretty sure if you ask more people, they will give you slightly different answers. But I hope the general gist of it will be this.
Thank you so much. And why is it very important to data scientists?
Well, I believe it's some kind of benefit for the company, right? You can cut costs of some stuff, right? You can optimize your processes. You can do smarter decisions. Yeah. So I think I know. I'm sorry that I'm repeating this point, but this is
It's okay.
my perspective. This is true. Yeah. This is how the data science is helping. Yeah.
So, what is the difference between business intelligence and data science?
Again, the definition's kind of different by the company, but in general, sorry, I'm a mathematician, so I try to answer like mathematically correctly. Yeah?
Okay.
By definitions, yeah. But in general, business intelligence, it's more trying to explain what already happened, and by some kind of standard tools like monitoring, graphs, and stuff like this, right? Whereas data science is using, first of all, different methods, so most like modeling methods, right? And mostly data science is actually trying to predict something in the future, right? Whereas business analysis is trying to explain something that already happened, data science is trying to explain something that will happen, or not even explain it, but predict it, or even give advice. If you would do step A, this and this will happen. Like, for example, this and this profit impact will be on the company. So approximately like this, but will be differ by each company, I would say.
So, what is there like any structure, and is there any best practices for organizing data science team?
I can talk about how we organize ourselves, right? So we are working in Agile, and we are operating in Kanban. I know that this is too much as well, a lot of buzzwords. Maybe let me say it in the human language. So basically, in Agile, it's more about trying to, have a lot of communication with your client and trying to deliver some minimal viable product and then improve on this minimal viable product. So you deliver something that is okay for client, then you get his feedback, and then you try to, iterate to improve it, right? And a Kanban, basically, this is that we plan our tasks dynamically, right? So we have a client, we prioritize. If there is some big priority, we assign it within our team. For me, also from data science structure, it works the best, at least for me, when it's outside of other departments, right? So we are departments of our own, which helps us a lot in communication with our client, in prioritization. And in general, it's quite fun because my team has opportunity to work on different departments' tasks, which is very interesting, right? Because they learn a lot of new things. So this is what works for our team, yeah, I believe.
All right, so is there any life cycle project of data science project, and how is it?
Well, for us, it's we first always meet with the client and try to understand how they will use our project, right? Our output of our project. We try to understand what will be the business impact. Based on this, we prioritize. Then we have some other initial call, more technical, and we try to get with the client on technical details. Like by client, I mean internal department, our internal client, right? So we try to get the technical details of the project. Then we usually start by collecting the data, the needed data, test the data quality, right? To make sure on what we built, it's reasonable, because in data science, the rule garbage in, garbage out is like very, very well known, right? Then we are starting to build a model. So we are picking the best model or best models that can be. Usually we start by the simplest one, because if the simplest one works, it's the best, because it's more interpretable, it's easier for implementation. And we go up and up, and we see how much we increase by each more added complexity. Then we start testing the model when it's over. Then we have also few iterations with the client when we show the models or the output, and we show them how it works. And then we go to implementation, which also sometimes takes a lot of time. Then we implement. After implementation, it still doesn't end, because then we need to monitor, right? Mm-hmm. What we did, it's basically sometimes making automatic decision, right? Mm-hmm. So we need to make sure it's always correct. So we set up some automatic monitoring, for example, that if some metrics is not correct, that we get automatically notified by email by our model itself, hey, something is wrong, you should fix the model, right? And then it's basically this monitoring stage, and then it's again rebuilding the model. It never ends, right? Because your model will get old in 1 or 2 years. It depends on which field and how dynamic and which market, but usually we rebuild the models once a year or once in 2 years, depending on which model. Some of them we rebuild even much more often. It really depends.
All right, so based on your explanation about the life cycle, there are like data preparations and stuff, right? And do you have any tips or pointers that you can give to us about what we need to prepare on that stage of data preparation?
Well, it depends on the project, right? Try to get as much data as you can, right? Make sure your data is not biased somehow. Make sure that you don't use, when you model information, I call it information from the future, right? Because when you model, you need to have some kind of, future info. When you model, you simulate your decision making at some historic time, and you get the data only what you have at this point, right? But actually, you already have the future, you already have outcome, right? So for example, when I model, I will keep the risk because this is, I think, the most closest one. So if I know which clients to default, I model it only on people who I know defaulted or not defaulted, right? Paid or not paid. But basically at the time, here I didn't know it when I do the modeling, but actually in reality, I already know it, right? So I need to make sure I don't use any data after this period, yeah. So it's probably too technical, right? But I hope, okay.
That's actually what we also need, because maybe our audience here also really wants to be a data scientist, but yeah, I think we need more pro tips from you. So we've been talking about creating models, right, as data scientists. Do you also have any pointers or maybe tips on creating models?
Well, this was what I said, start simply. Yeah, don't like many big starting data scientists have some kind of tendency to start with the most complex models because they think they are the most advanced. This is not a good approach in many cases because usually it tends for you to not understand the data, right? Which you should understand always when you do the modeling. And also if the models are too advanced, maybe you can also not understand what model did, and you can have some kind of incorrect relationship in your model, right? It's the one that you don't want to have there because sometimes the data is biased and you cannot fix it, yeah. But if you understand your model, you can understand this bias and you can, overcome it. There is ways. If you don't understand it, you might end up with the bias, with the model that on paper looks very good, but in reality, it will not help at all. Like we've seen such models. Like, I don't know, many years ago, we did something with some partner, like it was not in Indonesia. I will not name, but basically, when they showed our result, it was very good. But when we went to production, it basically didn't help at all. And this was exactly because of this. And this happens quite often. Yeah, so this is a very important point to really understand the data, understand the models, and only then you can reach correct conclusion, even for the prediction of the future, right?
All right, so talking about bias, how do we identify if the data is biased or not?
Again, the bias, this is very difficult. Basically, usually, because it's for every project different, right?
Yeah.
So there is no general rule, but in general, you will see something illogical in your data, right? And it depends what kind of bias. For example, I will again go to risk. In risk, we have observation bias, right? So we have some underwriting process when we decide if we reject or approve client. The problem is then when some of the people we reject, right? Because we see that their risk is too high. But if we reject them, it's already, then we don't have data from them. We don't know how would they behave if we would approve them, right? And then next time we build a model, we are missing this data. And this can cause very strong bias. Yeah, that even because of this bias, this is called reject inference, this one specifically. And it can happen that even predictors that are very logical will behave very strange. Like for example, this is typically with predictor, like for example, days past due. Days past due, it means how delayed the customers are on their current payments, for example, in credit bureau, right? So normally, logically, the higher the clients have the days past due, the more risky they are, right? Quite logically. If they don't pay other loans, they will probably not pay your loans, right? The problem is with reject inference. If you reject all of these people, for example, right? Let's say your old model rejected almost all of them and only few remained. Actually, by the definition, only the best of these worst people will remain. So all of a sudden you will see that people with the high non-payment are actually in your data the best people, which is not correct. It is just the observational bias that makes you see that, right? So yeah, there's many other observation bias, but this is like one example.
Thank you for that. And so maybe this is also something that the audience might want to take notes. So what kind of application that data scientists need?
What kind of, sorry, what?
Application. Is there any application? Yes.
You mean like software?
Yes.
Oh, I definitely recommend Python or R. Like Python on R or R, this is like the best, from my perspective, one of the best softwares for data science. First of all, they are freely downloadable, right? So you can basically install it on your computer without any licensing fees or anything, right? Because it's open source. Also, you have a large community of people because of this, and you have a large community of people from academia. So these softwares really like move very fast in development, and you have a lot of guides on them because really a lot of people, you know, are the users. So I would definitely recommend Python or R.
Thank you so much for that. It helps a lot of people, I'm pretty sure of that. And what are the biggest data set that you processed, and how did you process it? Like, what were the results of it? Do you want to share a bit of your experience here?
Like the data sets, like the biggest ones were probably few terabytes. And it all depends what kind of machine you are working on, right? So if you have few terabytes, this was actually when I did some project in India. I again cannot probably name, but basically then there was few terabytes because there is quite a lot of people, right, in India. And actually I had some behavioral data. So I had not like, you know, for one client, only one, one data point, but for one client, I had like, for example, more months of his behavior of the client. So this is very large data. So basically how I had to proceed, but luckily the partner on whose data I was working provided me with big machine. So I was able to somewhat fit it, but I was working partially, right? So I, for example, first did some parts. So let's say I grouped somehow logically some predictors. I worked first of them, chose the best one from this, best one from that, or start on different level of granularity. What worked for me, I started to do much more details. So basically aggregation is the solution, aggregation and separation. But I'm pretty sure, again, it depends on what kind of data you are working for, what kind of project. Sometimes this approach will not work. Yeah, it's my concrete project that I worked with. But in general, in home credit, we have quite interesting that we have quite large data, right? We are quite big on most of the markets where we are. And like very interesting is, for example, working on Chinese data. I don't remember, but on some months we had quite, big number of new clients. Since I don't remember, I will not say the number, but it's like very nice, very big and very interesting for data scientists because most of the advanced methods are very data hungry. The more data you feed them, the better the result.
Okay, so also based on your experience, what does a data scientist need the most?
Well, if I say one thing, I would say common sense. Yeah, really. Like you have to really challenge a lot of stuff and really think about it a lot. So if I say one thing, it's common sense. If it's not about his skill, but generally, I think it's support from the management and correct ways of support. Yeah, because if you have managers, which I'm glad to say in home credit we have, who really try to understand what you do, and they try to have realistic expectations, and they listen what you tell them or explain to them, and they like this is the best because they this can help, but also support of the teams for whom you are working, right? Because again, if the team supports you, they know the business, they know what needs to be done. Even though you can build a model, you don't know the business part, and maybe you built a model that is actually unusable or is predicting something very strange. So the second thing is probably support, either from management or from your client.
All right, thank you for that. And does a data scientist need to be better at statistics than a software engineer, and better at software engineering than a statistician? So like,
yeah, that's good. That's good point. Good comment. I fully agree with this one. Yeah, like somewhere in the middle. Yeah, so you have to be. Yeah, it's true.
So that's true. All right, confirm, guys. And how do you handle missing data? What imputation techniques do you recommend?
Well, it depends the reason for the missing data. I'm sorry, I'm answering so generally, but
it's fine.
Every use case. This is why you have to have critical thinking, because in data science, in every use case, you will deal with it differently, right? So in some cases, you just ignore it and you just delete the rows with the missing data. This is the simplest approach. Obviously, this is not good for many reasons. Yeah? And sometimes what we do, actually, sometimes the missing data also contains information, right? So let's say you have credit bureau, data, and you don't find client in the credit bureau, right? Credit bureau is some company that is, having all the credit information about the client, and they are providing it to the banks and financial institutions. So basically, if this credit bureau, you don't find the client there, it probably means he never took a loan before, which actually is all the information. It is not missing data, it is information, right? If the missing data is because of some random noise, then you can input the average, of the expected value. Sometimes you use the nearest neighbors, but honestly speaking, this one I do not recommend. We tried it a few times and it did never work in finance. Yeah, and again, what I tell you in finance can be not applicable. Maybe in other field it works, right? But for us, for example, imputing by nearest neighbors, it doesn't. Yeah, it didn't bring any benefit. So for example, this is the idea. If you don't know client, for example, age, you try to, impute it. You try to find automatically on your database clients who have same other demographic information or other information, and then you input the age by the other information of the similar clients, right? Could work. For us, it never helped, to be honest. So yeah, so these are some methods.
All right, so we're also going to talk about plagiarism, data plagiarism. So how do you usually come up with, like, what solution that you do come up when it comes to data plagiarism?
So, sorry, what is data plagiarism? I'm not sure.
So like maybe there are like data that that is like doubled.
Oh, duplicities. Sorry. Okay.
Duplicities. I'm sorry. Okay.
Oh, so okay. No, duplicities we simply delete. Yeah, like it doesn't make sense if let's say by some mistake you have someone in for example, client twice in your database. Well, you simply delete it, yeah, because it will skew your sample, right, towards the clients who are duplicate. So this one you usually delete. Yeah, there is not much else to do.
All right. So, is there anything called the curse of big data?
Yes.
What is that?
Honestly, I forgot the definition, to be honest with you.
All right.
I know I heard about it and I know we discussed it, but I now really don't remember. Either it is the fact that basically when you have more and more data, it's much harder to make some, it's harder to operationally work with it, right? Which I don't know if this is it. I don't remember. Or it could be the fact that if we have that basically no, this is data dredging, so it's not this. Basically, it's the problem. Let's say if I generate too many predictors, right? If I generate 1 million predictors and they will randomly start working, some of them just by random, right? Even though they shouldn't be predictive, but this is data dredging. It's not curse of big data. Sorry, I
All right.
I heard it somewhere, but I forgot now the
It's
definition.
okay. It's all right. So, well, maybe the curse does not really apply it on you.
Okay.
Hopefully, yeah. And what do you think is something that makes a good data scientist?
Well, on top of what I said, right, the critical thinking, ability to explain, I would say it's also like ability to communicate in general, right? Like maybe people, a lot of people think the data science is for geeks, which is probably partially true, right? But you know, it's also about you really need to communicate your results. Like if you have great results, but you cannot persuade your client to actually use them, you know, it's same as you didn't have good results, right? So it's also about communication skill.
Okay. And also, what will you say that is the best practices in data science? Do you have any?
Well, for me, always is understanding, right? And simplicity, starting simple. I think it will always help to start simple and then move up to more difficult methods. Yeah.
Okay. And what are your top 5 predictions for the next 20 years when it comes to data science?
Well, I definitely think it will start being less buzzwordy. So probably less buzz around it. But and on the other hand, at the same time, I believe the real use cases will be increasing, right? So I believe now, and I've seen some graph, I cannot cite it, so I don't remember where I've seen it, but I've seen some graph that data science is now like every new invention, like for example, 3D printing and blah, 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 right? They always have some kind of curve. When first is like excitement level and second is like, you know, like the real use cases, yeah? And always everything starts at the super exciting, but not real, that many real use cases. I think data science already passed it. We are already having real use cases, but still excitement is quite high. I believe it will be a little bit normalized, but at the same time, I also believe it will be, you know, having actually more impact than it had before.
Wow. All right. Because this is like, we're still kind of in a development in this area. Do you think so?
I would say so. I would say so. Like I believe there is many companies and many departments who do not use data science methods that much. So I believe there is a lot of low-hanging fruits still in data science that they. Yeah.
And would you please also give us like a big or like a general picture of how is the development of data science and the data scientist world in the world right now, or like in Indonesia specifically? Like how's the development?
I think, like again, same as in the world. I believe now it's as well in the buzzword phase. Maybe a little bit more even than in, let's say, Europe. It's maybe a little bit more in buzzword phase. But I believe there are now many teams whom we cooperated that starting to do like really proper data science that is making a lot of actual benefit. Yeah. Otherwise, I think it's a good field in Indonesia, definitely. I definitely think it will grow in many, many years. I still believe there is much place to grow. So yeah, my personal opinion about.
And do you think that the government needs to adopt this type of method to actually use data scientists for making policies probably? Like, do you think it is important?
Well, personally, I think so, but I'm obviously not qualified to, you know,
Oh.
about what government should do. Like, I think so. I think it will, of course, help, right? I believe that data science, if used properly, I think it can help in any aspect of the, you know, of the life. So I believe so. Like I have a friend in Czech Republic. I hope I can say it. Basically, my friend, even he was buying a car. He's data scientist, by the way. He's buying a car, so he built some automatic model that told him what is the best price. And because of this, he saved quite a lot of money because this model was actually looking on the, you know, on the websites automatically, comparing, and it told him, okay, this is the best price. So, you know, theoretically, you can use data science anywhere.
All right. So what is the latest data mining book or article that is that you can recommend to people that you have read?
Like definitely the people try to check the articles about LGBM XGBoost, which is not that late, but it's still, I would say, quite relevant. Definitely to learn about text mining methods. Like I don't have one very specific article that I would say this is the one, right? Like it's a lot about reading a lot of stuff, and it depends what kind of things you need to do, right? But I believe there is a lot of articles, and especially for your topic, what you need to now achieve. Like just search for that one. Yeah.
Mm-hmm. All right. Thank you so much for that. I'm pretty sure a lot of people would need it. And also, what are your favorite data science websites?
Well, I really love the Kaggle. Yeah, as I already mentioned, we actually, as Home Credit, a few years ago did a Kaggle competition, which was very interesting for us. And I think it's great because you can check that they have great community that is helping each other. They are even publishing their scripts. You can have a lot of rich data sets. Like this is definitely one of my favorites data science websites.
All right. Is there any words of wisdom for data science students or practitioners that is starting out that you can share?
Well, try to have competitive advantage, right? Try to really understand what you are doing. Try to make it practical. Try to simplify, and try to very well explain to your client. And then don't forget these are the people you are doing it for. So really take their feedback very seriously, yeah? And try to speak in their language. Don't expect them to understand your technical terms, yeah?
Okay. And what are the biggest areas of opportunity or questions you would like to tackle?
Like for me, we are now trying to utilize a lot external data, right? So we were working with the partners who provide some data to us, some big data, which is nice. And this is very helpful, but I would like to also for us to try to utilize more the internal data, right? As every company, right, there is so many data generated, and we are trying to use some of them, but I still believe there is so much potential in even using our internal data that we are not fully utilizing. So this is, at least for me and my team, this is the plan for next, let's say, 1 or 2 years.
All right, so is there any hope or anything that you want to share to a lot of data scientists out there?
I think I said already everything, but thank you all very much for watching. I hope it was somehow interesting for you.
All right, thank you so much, Kirill, for sharing us a lot of things and based on your experience, your knowledge, and yeah, we are very happy that you are able to be here with us. And also, I would love to ask you to say our tagline, Tech for ID's tagline. It is Tech for ID, technology for Indonesia, technology for everyone.
Okay. Tech for ID, technology for Indonesia, technology for everyone.
Thank you so much. Thank you so much, Kirill, for your time and
Thank
everything.
you for having me.
Thank you so much. It's been such a pleasant interview. So thank you, people, everyone, for tuning in today. If you guys have not watched the whole interview, it's okay because later Tech for ID will be uploading the video on their YouTube channel. So tune in to our YouTube channel and don't forget to subscribe. And yeah, thank you so much. See you guys later to another live tech talk session. Bye-bye.
Thank you.